This is Mrs. Zappia with Lesson 7 from Module 3, Understanding Equations. Student outcomes from this lesson. Students understand that an equation is a statement of equality between two expressions. Students build an algebraic expression using the context of a word problem and use that expression to write an equation that can be used to solve a word problem. Pause the video and copy the essential question for Lesson 7. How do you create an equation? How do you determine if a number is a solution to an equation? Key terms for this lesson. A variable is a placeholder for a number, such as x or r. An equation is a statement of equality between two expressions, and it has an equal sign. For example, 2x is equal to 14. A number sentence is an equation with numbers only. It can be true, 4 plus 3 equals 7, or it can be false, 4 plus 3 equals 8. A statement of equality or inequality between two numerical expressions also, such as 2 plus 7 is equal to 3 plus 6. And a solution is a number that makes the equation true. For example, the solution for 2x equals 14 is x equals 7. The solution is 7. Pause the video and copy the vocabulary terms into your notes. Pause the video to complete the opening exercise. After you have completed the top half of the page, resume the video to check your solution. The goal for this lesson is to learn how to build expressions and then write equations from those expressions. In this problem, we're going to start with the 14 feet. And we know that each picture is 4 feet wide. And so we can use a pen. And we can subtract the pictures to see how much space is left over. So we start out with the 14 feet. And we take away 4 feet for each picture. And that leaves us with 6 remaining feet to split up between the 3 spaces between the pictures. Then we take that 6 feet and we split it 3 ways, and that leaves us with 2 feet. So we have 2 feet between the wall and the picture, 2 feet between the wall and the picture, and 2 feet between the pictures. Now we want to write an expression to show the total length of the wall. So we have 2 plus 4 plus 2 plus 4 plus 2. That's 2 feet plus 4 feet plus 2 feet plus 4 feet plus 2 feet. This is based upon already knowing the answer. You can also think of this as 3 groups of 2 plus 4 plus 4. Also, you can think of that as 3 groups of 2 plus 8. Suppose we wanted to solve the problem using algebra, and we didn't know the answer is 2 feet. Let's let the distance between the picture and the nearest edge of the wall be x feet. Now, let's write an expression for the total length of the wall in terms of x. So here we would have x plus 4 plus x plus 4 plus x equals the whole distance of the wall. So let's write that as an expression. X plus 4 plus x plus 4 plus x. And that is the expression for the total length of the wall. You could combine like terms. We have 3 x's plus 4 plus 4. And you could even simplify that and say that that's 3x plus 8. Setting the expression equal to the total length of the wall described in the problem, which is 14 feet, gives us the equation. So let's write that equation. Again, setting this equation, which is the distance for the whole wall, equal to the whole wall will give us an equation. So we'll write that as x plus 4 plus x plus 4 plus x. And again, that is the distance for the whole wall, and we know that that is equal to 14 feet. Now let's combine those like terms, x, x, and x. So that's 3x plus 4 plus 4, and that is equal to the whole length, 14 feet. We can also combine our constants, and that will give us 3x plus 8 equals 14. So here we have an equation that will tell us, or that we could use to solve to find the distance between the wall and the picture for each section. Now, use your answer from the opening exercise. We haven't actually checked your answer yet. Use your answer and see if you put it in this equation and it makes it true or false. So what you're going to do is you're going to replace x with the answer that you found. When I did the problem, I got an answer of 2. So I'm going to substitute. I'm going to take the x out and I'm going to put the value of 2 feet in. And I'm going to evaluate that equation to see if it's true. Following the order of operations, multiplication first. So 3 times 2 is 6, and 6 plus 8 equals 14. And this is a true statement. So since this is a true statement, my answer of 2 is correct. And that makes 2 the solution to this equation. 2 is the solution. Another way to say that is x equals 2. Your parents are redecorating the dining room and want to place 2 rectangular wall sconce lights that are 25 inches long along a 10 2/3 foot wall, so that the distance between the lights and the distance from each light to the nearest edge of the wall are the same. Design the wall and determine the distance. Drawing a diagram is a good way to solve these kinds of problems, and they've already done that for you here. And notice that it's very similar to the one that has the pictures. What I want you to notice here is that the distance on the lights are 25 inches. So our unit of measure there is inches. Yet they give us the distance for the entire wall in feet. So we want to convert one unit to the other unit so that we're working within the same unit of measure to solve the problem. So we're going to actually convert both of them. We're going to change the feet to inches and work with the equation that way. And we're going to change the inches to feet and work with it that way and determine which is the most efficient way to do that. So first, let's convert inches to feet. Remember that there are 12 inches per foot, and we have 25 inches. So 25 inches, and we want to put that into groups of 12. Divide that by 12. That's 2, using up 24 of the inches with 1 left over. So we have 2 and 1/12. So 25 inches is equivalent to 2 and 1/12 feet. Let's label this one as well, 1 and 1/12 feet. Then I also want to convert the 10 2/3 feet to inches because we are going to work with the equation both ways. So 10 2/3 feet. Remember that a mixed number is a sum of the parts. So we have 10 plus 2/3. And we want to convert that to inches. So if we have 10 feet and there are 12 inches in each foot, we want to multiply that by 10. Well, we have 10 2/3 feet, so we want to multiply that whole quantity times 10, times 12 inches per foot. So we're going to multiply this whole quantity times 12. We're going to multiply the whole quantity times 12. And this is a good use of the distributive property. We want 12 groups of 10 to tell us how many inches in the 10 feet, and 12 groups of 2/3 to tell us how many inches are in that 2/3 of a foot. So 12 times 10 plus 12 times 2/3. 12 times 10 is 120, and 12 times 2/3 is 8. 12 times 2/3. That's 12 over 1 times 2 over 3. Simplify first. 3 goes into itself once. 3 goes into 12 4 times. 4 times 2 is 8. 8 over 1 is 8. And so that's 128 inches. So we'll label this. This is equivalent to 128 inches. And now we're free to either use feet or inches for the problem. Let the distance between the light and the nearest edge of the wall be x feet. write an expression in terms of x for the total length of the wall. So let's just sketch that diagram again. And here's our pictures. And let's see, it said in terms of feet. So we determined that this is 2 1/12 feet, and this is 2 1/12 feet. Write an expression in terms of x for the total length of the wall, and use x for the nearest edge of the wall. So this distance is x, this distance is also x, and this distance is also x. So writing an expression, we know that if we add x plus 2 1/12 plus x plus 2 1/12 plus x, that is the distance for the whole wall. Then use that expression and the length of the wall given in the problem to write an equation. So this length for the wall is equivalent to the whole distance of 10 2/3 feet. So this is our equation. We can simplify that. We do have like terms. We have x, x, and x. So let's go ahead and combine that. That's 3x. And we also have 2 1/12 plus 2 1/12. So we can combine those distances. And that gives us 4 2/12, which simplifies to 4 1/6. So we've got 3x plus 4 1/6 is equal to 10 2/3. So this is an equivalent expression that you could use to find the distance of x. Next, now write an equation where y stands for the number of inches. Let the distance between the light and the nearest edge of the wall be y inches. So let's go ahead and sketch our drawing. We've got our lights here. And we know that this is 25 inches, and this is 25 inches. And it says to use y for the distance between the pictures and the wall. Write an expression in terms of y for the total length. So if we add y plus 25 plus y plus 25 plus y, and that is the length of the whole wall. Now use that expression and the length of the wall, write an equation. Well, we know that the whole length of the wall is equal to 128 inches. 128 inches represents the whole wall, and y plus 25 plus y plus 25 plus y also equals the whole length of the wall, so they are equivalent to each other. We can combine our like terms. So we have 3y plus 25 plus 25 equals 128, and we can also combine our constants. 3y plus 50 equals 128. So now we have an equation that we could use. The first one will find the answer in feet, and the second one would find the answer in inches. What value of y makes the second equation true? So our second equation is right here, and we're going to write it here. 3y plus 50 equals 128. And we have three numbers to try, either 24 inches, 25 inches, or 26 inches. So since we have three numbers to try, we're going to keep this over here on the left side, and we'll write the equation over here to try the second number. And I'm not sure if I'm going to need to use the third number or not, so I'll wait and see. Now it says to try 24 and see if that makes it true. So what I want to do is I want to take y out, and I want to see if 24 inches is the answer. In other words, is this 24, 24, and 24? Would that total 128? So I'm going to substitute, take the y out, and put the 24 inches in. Add the 50 inches from the two lights and see if that equals 128. So 3 times 24 equals 72. 72 plus 50. And I'm just bringing down the 128 on the right side of the equation. Now on the left side of the equation, this equals 122. And 122 equals 128 is a false statement. And since that is true, we know that y does not equal 24. So now let's try 25. So what we want to see now is this number 25? So is it 25, 25, and 25? So we have three groups of 25 plus 50 equals 128. Three groups of 25 is 75. Bring down the rest of the problem. 75 plus 50 is 125 equals 128. This is false, and that means that y does not equal 25. So we'll try 26. Write down your equation. 3y plus 50 equals 128. 3y. So we'll take the y out and we'll substitute the 26 and bring down the rest of the problem. So what we're doing right now is we're checking to see if a number is a solution or not. And how you do that is you substitute the number for the variable and you evaluate that side of the expression and see if it matches. If it makes a true statement, then it is a solution. If it makes a false statement, it is not a solution. 3 times 26 is 78. Bring down the rest of the problem. And 78 plus 50 is 128. Since this is a true statement, we know that y equals 26. So it said what value of y makes the equation true? The value is 26. And again, this is called the solution to the equation. The ages of three sisters are consecutive integers. The sum of their ages is 45. So let's go over what consecutive integers mean. That means in a row. For example, three consecutive numbers might be 8, 9, and 10. Three more consecutive integers would be, let's say 13, 14, and 15. So we're looking for the ages of the three sisters, and they are only a year apart, and the sum of their ages is 45. The sum of their ages means that if we add their three ages together, it equals 45. Use a tape diagram to find their ages. So we'll use a bar to represent the youngest sister. And also just a random length. And then the second sister, we know that when you're using consecutive numbers that the second person would be 1 year older. So we'll make the bar the same length, but then we'll add 1 year because she would be a year older. And then the oldest is the same age as the younger one, but a year older than that. So we have the youngest, who is this old, and then the next older is 1 more year, and then the one older than that is 2 more years than the youngest. See, if this is the youngest person, then the middle daughter would have 1 year older, and then the oldest daughter would be 2 years older. So this is the 1 year older, and this is the 2nd year older. Now we know that the sum of their ages is 45. And that means that if you add all of those together, then that would equal 45. I know that this represents 1 year here, and that this represents a year, and this represents a year. So this section, I don't know what it is, but I know that there are 3 of them. So I have 3 of something plus 3 more years equals 45. Well, if I take the 3 years off the 45, that equals 42 years. And that 42 years can be split evenly between these 3 bars because they are the same. So 42 divided by 3 equals 14. And that means that this length is 14, so that the youngest is 14. Then the second one is 14 plus 1 more year. So that means the middle child would be 15. And then the oldest, this represents 14, plus 2 more equals 16. So the consecutive ages are 14, 15, and 16 years old. And let's just double check to make sure that that adds up to 45. So 4 and 6 is 10, plus 5 is 15, and it does add up to 45. The youngest sister is X years old. Describe the age of the other two sisters in terms of X, and write an expression for the sum of their ages in terms of X. All right, so we have the youngest, and it says to use her age as X. And then we'll call this one the middle child. And we know that that is 1 year older. So if this bar for the youngest is X, then the middle child would be X plus 1. And then the oldest, this is the bar that is X, so that would be X plus 2. So it says, describe the ages of the other two sisters in terms of X. Okay, so we've done that. Now, write an expression for the sum of their ages in terms of X. So to write an expression for the sum, that means we're going to add those three together. So we have X for the youngest, plus X plus 1 for the middle child, plus X plus 2 for the oldest child. Now use that expression to write an equation. So an equation is when you know what this is going to be equal to. And we know that it is going to be equal to 45. So now we have an equation. This is the equation that could be used to find their age. Now determine your answer from part A is a solution to the equation you wrote for part B. So the age that we came up with was 14 for the youngest sibling. And so we want to know, is that correct? So I'm going to substitute 14 for each variable X and see if that's correct. So we have 14 plus 14 plus 1 plus 14 plus 2. And I want to make sure that's 45. So this is all addition. So I can regroup this if I choose to, or I can add it the way it is. I'm going to go ahead and add it using the order of operations. So I'm going to do the parentheses. 14 plus 1 is 15, and 14 plus 2 is 16. And now 14 plus 15 is 29, and 29 plus 16 is 45. So I have 45 on the left and 45 on the right. So this is a true statement, and that proves that my answer is correct. We are going to skip this exercise and go down to the summary. In this lesson, you have learned to determine if a number is a solution to an equation. Substitute the number into the equation for the variable, which is the letter, and check to see if the resulting number sentence is true. If it is true, then the number is a solution to the equation. For example, 7½ is a solution to 2n equals 15 because 2 times 7½ is 15. Word problems can be challenging. Think about this strategy. You needn't copy it into your notes. In many word problems, an equation is formed by setting an expression equal to a number. To build the expression, it's helpful to consider a few numerical calculations with just numbers first. For example, if a pound of apples cost $2 and 3 pounds would cost $6, $2 times 3 pounds, and 4 pounds would cost $8, $2 times 4 times a pound, then n pounds would cost 2n dollars, because we've figured out that we multiply 2 times the number of pounds to get the cost. So if we had $15 to spend on apples and wanted to know how many pounds we could buy, we used the expression 2n. That is the cost of the apples, and n is how many pounds. So then we write an equation because we have $2 times the number of pounds, and we have $15 to spend. Then we can use that to find the answer, which is 7½ pounds. So yes, word problems can be challenging, but a good strategy is this process.